Today's video lesson will be on angle measures and segment lengths within a circle. Objectives: to find measures of angles formed by chords, secants, tangents, to find the lengths of segments associated with circles. So you should be able to do those two items at the end of this video lesson on your own. So let's jump right to it. So, the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So if we have a circle, and I have two chords that intersect each other, that do not go through the center of the circle, I can find the angle formed by the intersection of the two chords. So I can find angle 1 here. So angle 1. I can find angle 1 by taking arc measure AB and arc measure CD. So in my diagram, angle 1 is going to equal the measure of arc AB, okay, plus the measure of arc CD, and then timesing it by a half, or dividing by 2. So let's do an example. If I say that AB arc is measuring 50 degrees, CD arc is measuring 75 degrees, so I can find angle 1. So angle 1 is equal to the measure of arc AB, which is 50, plus the measure of arc CD, which is 75, and timesing it by a half. So if I have 50 plus 75, I have 125, and I take half of it. So I take half of 125, I get 62.5. So angle 1 is equal to 62.5. So this is 62.5, this is 62.5, and don't forget that angle 2 is linear to angle 1, so I can do 180 minus 62.5 and get 117.5. So angle 2 is 117.5. This is 117.5. So to get the angle formed by two intersecting chords that do not meet at the center of a circle, you take the sum of the intercepted arcs and then divide by 2. The measure of an angle formed by two lines that intersect outside of a circle is half the difference of the measures of the intercepted arcs. So if you want to find a circle on the outside, you take the arc measures, subtract the difference, and then divide by 2. So example, I'll do all three examples. If I have a circle and I have two segments that meet outside the circle, so I'm going to have angle 1. So I'll have A, B, C, and D. So angle 1 is going to be equal to the measure of arc AB minus the measure of arc CD times a half. So to do this example, if A to B was 100, C to D is 30, I know angle 1 is the difference, so 100 minus 30 times a half, so I have 70 times a half, so angle 1 is equal to 35. I'll do a diagram where you have a tangent. So I can adjust my diagram Let's adjust my diagram. Here we go. So I can still find angle 1. I can still find angle 1 on the outside. Here's A, B, C. So I can find angle 1 because it's on the outside if I take the difference of the two arc measures. I take the arc measure of AB, subtract it from the arc measure of CB. So if AB was 120, CB was 30, I know that angle 1 in this case is going to be the difference, 120 minus 30 times a half. So 90 times a half, so angle 1 is 45 degrees. So if the angle is formed on the outside of the circle, take the two arc measures, take the difference, and then divide by 2. Last example. If I have a angle 1 on the outside and I have just A and B, so you should know that CD, this is a tangent, this is a tangent, okay? Two tangent lines touch the circle once and only once, also perpendicular to the radius. Don't forget about that. So I can have the major arc, I'll label this D. So in this case, I know that angle 1 is going to equal again to the measure of arc ADB, subtract the measure of arc AB, and then times a half. So if ADB is 210, and then AB is 150, I can find angle 1 by doing the difference. So angle 1 is going to be 210 minus 150 times a half. So 210 minus 150 is 60. So half of 60 is 30, and angle 1 is 30 in this case. So there's 3 examples where your angle is on the outside of the circle. You take your two arc measures, do the difference, and then multiply by a half or divide by 2. So let's actually apply this for some more examples. So here you have two chords inside the circle intersecting that are not intersecting at the center of a circle. So I know that x is equal to the sum 90 plus 46 and then multiplied by a half. So 90 plus 46 is 136. So x is 136 times a half, which is the same as dividing by 2, which is 68. So x is 68. So here I have my angle that's on the outside. Z is actually an arc measure that I need to find. So I know in this case that 20 is equal to 95 minus Z times a half. Solving for Z, I multiply both sides by 2. So now I have 40 equals 95 minus Z. Subtract 95 from both sides. So I have 40 minus 95. I have negative 55 equals negative Z. Therefore, divide by negative 1. Therefore, Z is equal to 55. Let's apply this more. So in example A, I have the angle that's on the outside. So if your angle is on the outside of the circle, you know you have to take the difference of the two arc measures. So I know that 70 is going to equal to the difference of the arc measures. So W minus 110 times a half. So therefore, to get rid of my fraction, I know that's going to be 140, multiply both sides by 2 to get rid of my fraction, equals W minus 110. Add 110 to both sides, and I have 250 equals W. Again, for example B, my angle's on the outside, therefore I take the difference of the two arc measures and multiply by half. So y is equal to the difference of the two arc measures, so it's going to be 110 minus 30 times a half, so y equals, so I have 110 minus 30, which is 80, times a half, so y is equal to 40. Be careful for this example C. The angle is on the inside, formed by two chords, therefore it's the addition of the two arc measures times a half. So I know that 35 is equal to the sum of the two arc measures that are on the circle times a half. So I have 70 equals x plus 30 minus 30 from both sides. So 70 minus 30 is 40. So x is equal to 40. You can also find segment lengths with a circle. So you have your chord rule, secant rule, and a secant tangent rule. A secant line, okay, a secant line goes through the circle twice, whereas a tangent line, again, touches the circle once. So you have a chord rule, so two chords on the inside of a circle that intersect not on the center of a circle. You can find the lengths by taking the product of the segments from the intersection point. So C times D is going to equal A times B. Your secant rule, I know these are secant lines because they go through the circle or they touch the circle twice. I know it's going to be W plus X times W equals Y plus Z times Y. So it's basically the whole length, okay? W plus X is the whole length, and this is the whole length, okay, times the outside. So that's the outside, that's the outside. So the secant rule is the whole times the outside equals the whole times the outside. And then you have your secant tangent rule. Again, the secant line touches the circle twice, the tangent touches the circle once. So this is the whole times the outside is going to equal to the outside squared. And you'll see some examples. So these are segment lengths, again, not angle measures. So first of all, you want to identify the rule. So in this example A, I know that I have two segments that touch the circle twice. Therefore, this is the secant rule, which states that it's the whole times the outside equals the whole times the outside. So I know it's the whole thing, so it's the whole times the outside is going to equal the whole times the outside. Well, if I take the whole, I'll take A, B, and C. So the whole is AB, okay. The outside is 7. The whole is AC of the other secant times the outside, which is 6. Well, my AB length is 7 plus Y times 7. My AC, which is the whole length of the other secant line, which is 6 plus 8 times 6. So distribute, I have 49 plus 7Y equals 6 plus 8 is 14, so I have 14 times 6, which is 84. Minus 49, minus 49. I have 7y equals, I have 84 minus 49, which is 35. Therefore, I divide by 7, and I get y is equal to 5. Example B, I have a segment that touches the circle once, so this is a tangent. I have a segment that touches the circle twice, so that's a secant. So this is a secant tangent or tangent secant rule, which states that, okay, it's the outside squared is going to equal the whole times the outside. So I'll label A, B, C. So the tangent part, okay, the outside is z squared. The whole, which would be AC, the whole part of the secant is AC, times the outside part, which is 8. So I have z squared equals A to C is 8 plus 16. So 8 plus 16 is 24 times 8 is 192. So I have z squared equals 192. So z equals the square root of 192. So if I take the square root of 192, I get z is equal to 8 radical 3. If I wanted this rounded to the nearest decimal, okay, it'd be 13.9, which is about 13.9. Let's do some more examples. Okay, I have a secant rule, which is again the whole of one secant times the outside is equal to the whole secant of the other times the outside. So I'll label A, B, C. So the whole of one secant is AB times the outside of AB. The outside of AB is 14. The whole of the other secant is AC times the outside part of AC, which is 16. So AB is 20 plus 14, which is 34, times 14. A to C is x plus 16 times 16. So 34 times 14 is 476 equals 16x plus 16 times 16, 256. So 476 minus 256 is 220 equals 16x divided by 16. You get 55 over 4. So x is 55 over 4, which is 13.75. Example B, 2 chords. So this is your chord rule, which states that if I label A, B, C, D, E, so I know that A, E times B, E is C, E, going to equal to the product of C, E, D, E. Well, A, E is 6.5. B, E is 3. C, E, oh wait, sorry, B, E is M. B, E is M, not 3. C, E is 3. D, E is 7. So I have 6.5 M equals 21 divided by 6.5. So M equals what's 21 divided by 6.5 is 42 over 13. Which is about 3.2. So that concludes the video lesson with finding angles formed by two chords, angles on the outside formed by secants and tangents, and finding lengths of segments inside and outside of a circle. If you have any questions, raise your hand in class and practice the homework problems to master this skill set.